Today we're going to be doing the chapter 3.3 periodic quiz, and it's all about complex roots and whatever. Most of you guys have already done the periodic before, but you're repeating it. But let's start. Most of you already know how to do most of these. So what are the roots of this over the set of complex numbers? Now, personally, in the exam we're allowed to use calculators. So personally in the exam, if you get a question like this, solve it, then check with your calculator, or just if you don't have time, do it on your calculator straight up, because it does give you the answer. You could go to mode 5 then 3, or 3 and 3, depends on your calculator. Then but let me show you how to solve it. First of all, you have to find delta. Delta equals b squared minus 4ac. Now, what's a? A is 1. B is -4. C is 5. Now, b squared, so it's 16, minus 4 into 1 into 5, but 1 is the same as 4. So it's 16 minus 20, which is -4. Now, when it's negative, we know already from previous chapters that it has no real roots. So the roots that it does have are complex. So what's -4 basically? -4 is -1 times 4. What can we write -1 as? We can write -1 as I squared, right? Because I equals radical -1. So I squared would be -1. So what's -4? -4 is just 4i squared, right? Since we're on the same page, let's continue. So these two are the same. Now, to solve, we need to put this in our quadratic formula. What's the quadratic formula? It's minus b plus minus radical delta over 2a. Now, minus b is minus 4, which is 4, plus minus 4i, radical 4i squared, over 2 times 1, which is just 2. So, it's practically 4 plus minus 2i over 2. Now, what can we take out of this equation from the top? We could take out 2, right? So 2 into 2 plus minus I over 2. 2 will cancel out with the 2. We're left with 2 plus I, 2 minus I. Because 2 plus minus is these two. So these are your two answers. Now, pretty easy. Let's move on. Okay, so express the complex number in a form where a plus bi, where I is radical -1. Now, what do we know? We know one thing. Whenever we're looking at these, we have to do exponent divide by 7. 12 divide by 4, not 7. Divide by 4 equals 3. If you get a whole number, then that number, the entire thing, I is gonna equal 1. Whatever it is. If the power divided by 4 is a whole number, this is 1. So now 7 divided by 4 is going to be 1. 1 times 4 is 4, and so 3. Now what does that mean? It means it's I. Sorry guys, sorry, where was I? Yeah, so what this means is it's minus I to the power of 4 times 1 plus 3. Now we said whenever you have 4 plus 1, ignore. So it's technically I to the power of just 3. I to the power of 3 is just -I. So we could replace this by -I. And we have negative, which make plus, so 1 plus I. And that's your answer. Moving on. Now the next question is telling us which of the following is a factor, okay, it has more than one part, of this over a set of complex numbers. So once you factor them out, what two factors do you get? Now what do we know about 20? First of all, I think, yeah, we could take 5 out from both. We'd be left with 9x squared plus 4. Now, what can we replace plus 4 with? Plus 4 is basically negative 4i, right? Because I squared, my bad. Negative 4i squared. Because I squared is basically negative 1. Negative 1 times negative 4 makes plus 4. So that's basically what we have. So what does this look like? It's basically a squared, which would be, so 3x all squared minus 2i all squared. This is what it looks like, which is a squared minus b squared. A squared minus b squared is a plus b, a minus b. So 3x plus 2i into 3x minus 2i. All of these are multiplied by 5, by the way. But 5 isn't one of the options, so 3x minus 2i, 3x plus 2i. That's basically it. Now let's move on to the next part. Now, this is the same thing, just you're writing it over in the boxes. We said 5 is outside, then we have 3x plus 2i and 3x plus minus 2i. 3x minus 2i is the same as 3x plus minus 2i. It's just they wanted to throw you off, that's why they put it like this. It's the same thing I wrote. It's 3x plus 2i into 3x minus 2i. This is practically what they wrote down here. It's just here they wrote plus minus 2i. Same thing. Moving on. Now here you have two complex numbers. Z is negative 4 plus I, and W is this. 2 plus 6i. Now 5z minus 3w. How do you do 5z? 5 times negative 4 plus I, which is negative 20 plus 5i. You want all this minus 3w. What's 3w? 3 into 2 plus 6i, which is basically 6. You want all this into all this, which is 6 plus 18i. So negative 20 plus 5i minus 6 minus 18i. Negative 20 minus 6 is negative 26. And negative 18 plus 5 is negative 13i. And that's your answer. Again, be careful because they're going to try to throw you off by putting plus in the middle. You can write the negative yourself. Plus minus 13i is the same as minus 13i. They're just trying to throw you off. Now let's do the next part. Next part is 4z, which is 4 into negative 4 plus I, which is negative 16 plus 4i. And you have 7w, which is 2 plus 6i, which is 14 plus 42i. Now when we add these two numbers, negative 16 plus 4i plus 14 plus 42i, negative 16 plus 14 is negative 2, and 42 plus 4 is 46i. And that's our answers. Moving on. Given two complex numbers, same thing as last time, except here you don't need to multiply it by anything. Just 4, negative 4 plus 9i plus 5 minus 6i. Negative 4 plus 5 is 1. And 9 minus 6 is 3. I. Now for the second one, they want to do the same thing, but you need to subtract them. When you're subtracting, always put your values into brackets because it makes a difference. Minus 6i. Now you need to distribute the minus. So it's negative 4 plus 9i minus 5 plus 6i, because minus make plus. Now negative 4 minus 5, negative 9, plus 9i plus 6i, 15i. And that's your answer. Let's move on to the next question. Okay, so given that 7x minus 8y equals these, where x and y are real numbers, and what's the value of x and y? Now, in these types of questions, you have to do all the real numbers together and all the negative numbers together. What I mean by that is 7x equals negative 21. So x equals negative 3. Now negative 8, yi equals 4x minus 5y into I. Now what do we do here? I will cancel with I. You're left with negative y equals 4x minus 5y. We know x is negative 3 into minus 5y. So now we have here negative 12 minus 5y. What do you do now? You move all the like digits to one side. So negative 8y plus 5y gives you negative 3y equals negative 12. Negative will cancel with negative. You're left with 3y equals 12, y equals 4. And these are your two answers. Let's move on to the next one. So always remember, when you have like this, all the real numbers without an I beside them are equal to each other, and all the imaginary numbers with an I beside them are equal to each other. Moving on. Okay, so z times w equals. Now to do this, you have to put each one into brackets. 5 plus 4i into 2 minus i. Now you distribute like this, like we used to distribute with brackets like these. So 5 times 2 is 10. 5 times negative I is minus 5i. Now plus 4 times 2 is plus 4i is 8i. Now 4i times negative I is minus 4i squared. Now that we have everything, so 10 plus 3i minus 4i squared. Now what do we know I squared is? I squared is basically negative, so I squared equals negative 1. So we can replace this by negative 1. Negative 4 times negative 1 is plus 4. Now 10 plus 4 is 14 plus 3i. And that's how you reach this answer. Now let's move on to the next question. Let's solve a quadratic with complex roots. Again, first, you could definitely do this on your calculator and you will surely get the answer correct. But let's solve it manually. Delta, which is equal to b squared minus 4 into ac. Again, a is the one with x squared, which equals 1. B equals 6. C equals 25. And the formula is b squared minus 4ac for delta. And the quadratic formula is alpha equals negative b plus minus radical delta over 2a. This is alpha, by the way, not a. Now, 36 minus 4 into 1 into c. So 36 minus 100, basically, which is, let me do it on my calculator, 100 minus 36 minus 100, which is negative 64. Again, what did we say this is? We said it is basically 64 I squared, because I squared is negative 1. Now, let's solve. We have negative b, which is b is 6, so negative 6 plus minus del radical 64i squared all over 2. Now, it's basically negative 6 plus minus 8i all over 2. Now, what can you take out from the top? You can take out 2, right? So you're left with 2 and 2. Negative 3 plus minus 4i all over 2. 2 is going to cancel out with 2, leaving you with negative 3 plus 4i or negative 3 minus 4i. These are your two roots. Plus and plus, again, plus negative 4. They want to throw you off. That's how they write it. Moving on to the next question. Okay, so fill in the blanks with the correct numbers to represent the quadratic trinomial in factor form. Now, what do we do for these types of questions? Now, you have to do the same thing we've been doing. Find the answers first. Then I'm going to show you what to do next. So, delta equals 100, which is I squared, minus 4 into 41. Do it on your calculator. You're going to get, again, negative 64. Which is the same as 64, that's similar, which equals 64i squared. Again, we're going to put it in our quadratic, negative 10 plus minus radical 64i squared all over 2, which is going to give us negative 5 plus 4i, negative 5 minus 4i. You're going to say, okay, but they want x and whatever. How do you get these? Now, look, whenever you want to represent it in a factored form, you're going to write x, because it's x squared, right? So you're going to write two brackets starting with x. Now, you're going to try to oppose everything in this. If this is negative 5, you're going to write plus 5. If this is plus 4i, you're going to write negative 4i. Now, so for the second one, you're going to do the one for the second answer. Negative 5, so plus 5. Negative 4i, so plus 4i. And that's your two answers in factored form. X plus 5 minus 4i. X plus 5 plus 4i. That's basically all you're going to do. That's it. Now let's move on to the next one. No, wait. Okay, so you have two complex numbers, z and w. So, what's 2z? We did these types of questions before, but let's solve these ones now. 2z is 2 into negative 4 plus 9i, which is the same as negative 8 plus 18i. Now, 4w is 4 into 5 minus 6i, which is basically 20 minus 24i. Now, you want to add these two numbers. You could add them on top of each other like we used to do in grade 1. Negative I plus 20 is negative 12. And 18i plus negative 24i is negative... Wait, so how do you get from 18 plus 2? Plus 6. Negative 6, right? Yeah, negative 6i. That's how you solve for the first one. Now, let's do the second one. Same thing, just 5z now. 5 into z, which is negative 4 plus 9i, equals negative 20 plus 45i. All of this minus 5 minus 6i. Minus 6i. Now, negative 20 minus 5 gives you... Negative 20 minus 5 gives you negative 25. Plus 45 minus negative 6i, which is 45 plus 6i, gives you 51i. And that's your final answers for both of them. What the hell is this line? Anyways, doesn't matter because I'm moving on to the next question. Here you're gonna again multiply two complex roots. So let me write it down. Negative 3 plus 2i into 5 minus 9i. Negative 3 times 5, negative 15. negative 3 times negative 9i plus 27i. Now plus 2 times 5 is plus 5i. Now plus 2i times negative 9i, negative 18i squared. We said I squared is the same as negative 1, so we can replace this by negative 1. So negative 15 plus 27 plus 5 is basically 32i. Or wait, no, it's not. Wait, I did something wrong. It's 10i here. This is 10i because it's 2 times 5, so it's 37i minus plus 18, because minus 18 times negative 1 is plus 18. 18 minus 15 is 3 plus 37i. That's it. Now let's move on to the next question. Oh wait, that is the last question. Hope you understood everything. Have a great day. Bye.